running out of time, men and resources, Germany would pin their fleeting hopes on the strangest of hybrid aircraft, the Mistel. Hitler's plans for world domination were beginning to crumble. The Soviets had outlasted their invaders and were eradicating them from the territory. Soon the Allies would be storming in from the west, crushing the German forces from the other side. Without a heavy bomber to punish their foes, Germany created the Mistel. Fused together from the remains of their air force and packing an enormous bomb, it was hoped that the aircraft would stop the Allies in their tracks, or at the very least, slow them down. June 14, 1944, the first Mistel attack of the war is launched. It's a solitary affair, with just one Mistel against the greatest invasion fleet ever assembled. It was a mission doomed to failure. Picked up on radar, the lone Mistel was found and shot down by a patrolling RCAF Mosquito night fighter. The second attack occurred on June 24th.
The Mistel are commanded by an officer called Hauptmann Horst Rudat, a very experienced bomber commander, and after a lot of planning, 12 Mistel are armed and ready to fly. They can't fly in daylight because of the overwhelming Allied air superiority. So it is decided that the Mistel has to fly either at dawn or at dusk. The mission eventually starts at dusk.
4 elephant trunk Mistels, led by pathfinders and escorted by night fighters, set out for the fleet. The mission was a limited success. One Mistel was hit by friendly flak and forced to launch early, crashing into the sea. 2 had to separate due to mechanical issues, and only one Mistel was successfully launched. Released from a height of 275 meters, the explosive-laden bomber hit the sea close to the river-class frigate HMS Nith.
The guys on board Nith, men that I've talked to, recall hearing a very ominous sound. They heard a bomber getting closer and closer, and this was unusual because there weren't many German bombers in the sky at this stage, and one or two of the crew on deck looked up, and the last thing they saw was a twin-engine German bomber coming towards them at a very, very low level. The Ju-88 hit Nith amidships. It holed the ship, almost went through it completely. It sprayed, it just covered the vessel with steel fragmentation. It burst pipes, it damaged the engine room. The lights went out on the vessel, and she was catastrophically damaged. They immediately tried to conduct repairs. By morning, the ship remarkably was somehow still afloat. A dozen men had been killed, several others had been wounded, and that was a sign, a portent of what this weapon could do.
Fortunately for the Allies, the Mistel's contribution to the Battle of Normandy was piecemeal and ineffective. Surprised by its appearance, Allied intelligence quickly realized just how powerful the Mistel really was.
When the Mistel first struck, it was a surprise. And indeed, the crews of Allied night fighters, when they encountered this thing, they just wondered what the hell it was they'd come up against. They'd never seen anything like it, this great lumbering thing flying through the sky.
At the same time, it was extremely vulnerable to fighter interception and an easy target for flak. While extremely powerful, the Mistel was never considered a real threat to Allied shipping. October 1944. The Mistel's dismal performance in Normandy was not seen as a setback. Specialized units like KG-200, the Luftwaffe's Covert and Special Operations Unit, were equipped with the composite. a new model also appeared, the Mistel II. Replacing the Bf-109 is the FW-190F, mated to a Ju-88A4 or G model. The FW-190F offered a greater range and more power. By 1945, the military situation in Germany was dire. As more Mistels were built and the number of crews continued to rise, they faced a harsh and unforgiving reality. The Mistel was a specialized bomber designed to sink ships and heavy fortified targets. As the Allied armies closed in, there were fewer and fewer targets. For Reichsmarshal Hermann Göring, the Mistel was seen as an opportunity.
By late 1944, the Luftwaffe is fighting a losing battle. The skies over Germany are dominated by the Allied air forces. Germany is being bombed by day and night. Göring's prestige in the eyes of Adolf Hitler, the Luftwaffe's prestige in the eyes of the German people is sinking to an all-time low. They need to launch a spectacular. Göring has this almost childish belief that by launching a spectacular mission somewhere, he can retrieve some sense of respect in the eyes of his Führer.
Göring's prize was Scapa Flow and the pride of the Royal Navy. Codenamed Dragon's Lair, the plan was designed to sink as many British carriers and battleships lying at anchor. Based in Denmark, 15 Mistels were assembled for the attack. The training was extensive, but the chances for success were next to nil. Göring's target selection was not based on any military reality, but wrapped up in the delusional ego of a Nazi leader whose star had clearly fallen.
Göring and his staff officers believed that in the Mistel, they had the weapon with which to destroy battleships and, most importantly, aircraft carriers. They were the prime target. Tactically, strategically, there was really no benefit. This was purely for prestige and propaganda, and they believed they had the weapon which could be successful and achieve that aim.
On paper, Operation Dragon's Lair was a straightforward plan. 12 Mistels would take off, fly across the North Sea, and head to Scapa Flow. To avoid radar detection, they would fly at minimum height. Once in the target area, they would climb to 800 meters, select their target, and begin the attack. Each pilot was given a specific target, with the carriers being the ultimate prize.
Within the dozen or so group of pilots that were slated to fly this mission, there actually grew a sense of competition and rivalry among them, that each of these guys were jostling to get assigned the prime target. I'm going to be the one that gets the aircraft carrier. Word came through from Göring that they did it. Every pilot that got back, having hit a target, would be awarded a Knight's Cross.
The Mistel's presence in Denmark had not gone unnoticed. British air intelligence reported a large quantity of Mistel aircraft based on 2 Danish airfields. Shortly after, the RAF's highly trained fighter interception squadron was briefed for a special mission. Back in Denmark, the attack on Scapa Flow was imminent.
In February 1945, the weather clears, there's a window in the weather, the mission is on. The pilots are ordered to bed the night before to get a good night's sleep, and on the 6th of February 1945, the pilots board their trucks for the short journey to the airfield.
That night, the tables were turned on the Germans. 2 RCAF Mosquito fighter bombers race across the North Sea at 0 height. Their target, Tierstrup Airfield. Hugging the deck, the 2 Mosquitoes attacked the airfield from 2 different directions. Surprise was complete. According to German records, the 2 Mosquitoes destroyed 3 Mistels with 1 damaged. It was a stinging blow. For British intelligence, it was a clear triumph. But how did they know? German documents attribute the sudden cancellation of the operation to a lack of fuel. The recollections of those who took part paint a different and fascinating picture. Former Staffel Captain Balduin Pauli wrote after the war that he believed KG-200 commander Werner Baumbach deliberately betrayed the operation.
After the war, a couple of former German Mistel pilots received letters from Baumbach, who was living in Spain at the time, and he had said that he was extremely concerned that it would just result in a complete loss of very, very highly skilled airmen, that it would be a catastrophic disaster, that it would actually be a propaganda own goal, and that in his view it was insanity to launch the mission. There is a belief that it was betrayed by Baumbach with contact to the Danish underground, who reported it to London, and London sent the mosquitoes. And that is how Dragon's Lair was compromised.
What really happened cannot be confirmed or denied with absolute certainty. The result, however, remained the same. Operation Dragon's Lair was mercifully postponed. Incredibly, just as the pilots of Operation Dragon's Lair waited for their opportunity to attack, the Luftwaffe authorized a new and even more ambitious operation, this time in the east. It was called Operation Eisenhammer, Iron Hammer. More fantastical than the Scapa Flow attack, the new target was the electrical power plants deep inside Russia.
The origins of Operation Eisenhammer, Iron Hammer, originated with a man called Professor Heinrich Steinmann. And in 1943, he devised a plan using special floating bombs to be carried by Heinkel 177 bombers to strike at Soviet power stations behind the Ural Mountains. Now that never happened, but the idea lingered, and it lingered within the minds of certain members of the Luftwaffe General Staff. The idea was revised, and again, the German General Staff went back to the Mistel. The target was the power stations in the Moscow area and the Upper Volga area. They believed that by striking the power stations, Soviet war production could be affected and in certain parts halted. How to do it? Bring in the Mistel.
March 17, 1945. The orders went out. All Mistel crews and Pathfinder pilots assigned to the attack were ordered to Berlin. They received an intense week of secret briefings.
The pilots of KG-30 and KG-200 were briefed to an incredibly detailed degree. They had these big briefing halls, on the walls of which were these vast maps showing their approach routes, and not only that, but the plans of these turbine units. I mean, one power station, for example, at Stalingorsk, they were incredibly detailed.
It was an overly ambitious plan with no real hope of success. Navigating at night without the help of radar or radio aids would have been extremely difficult. Led by the Pathfinders, the entire force was to fly east across the Baltic Sea, cross north of Königsberg, and then head towards Moscow. Each power plant was assigned 6 to 8 Mistels, and once illuminated by the Pathfinders, the attack would begin. Incredibly, most of the pilots involved believed the attack would be successful. As the planning and training continued, Soviet forces cut deep into German-held territory. Vital airfields ready for the attack were lost, increasing the distance to the target. With the detailed briefings finally over, the pilots moved to their prospective airfields and waited. The call never came.
The United States Army Air Force was bombing at that point, and they destroyed almost half of the force on the ground. And because they couldn't replenish fast enough, they decided that the whole operation should be scrubbed.
For many of the pilots, the whole affair was deeply frustrating and disappointing. Their belief in themselves and their equipment stood in stark contrast to the hopeless odds before them. Ultimately, any victory would have been nothing more than a historical footnote.
By March 1945, yes, fuel had become a problem. Even moving a small number of aircraft, let alone 100 Mistel, to airfields in the extreme east along the Oder to get to Russia, it would just have been impossible. Flak, Soviet fighters, it would have really been a massacre. But the idea lingered, and people in the German General Staff believed right up until late March 1945 that the Mistel was capable of doing that. But the mission in the end was scrubbed.
The Germans had another plan to attack Soviet factories using a bizarre Mistel combination. In this desperate time, the designers at Junkers proposed marrying a Ju-290Z bomber with an Me-328 Parasite. This aircraft design was unconventional in two ways. First of all, the bomber was a Zwilling, or twin, meaning two aircraft were to be joined together at the wings to create one monstrous airplane. It was hoped that its additional range and power would enable Germany to strike at the heart of the Soviet industry behind the Ural Mountains. The only problem was, if Germany launched such a strike, it had no escort fighters with the range and maneuverability to defend this massive bomber. It could be obliterated before it even got to target. To solve this dilemma, the designers at Junkers made an even bolder design choice. They intended to marry it with a Parasite fighter, the Me-328. The Parasite was made mostly from wood and was powered by either two pulse jets or a rocket engine. It was specifically built to be a mini escort that was either towed or carried by a bomber to a target. The designers at Junkers constructed a platform atop the Zwilling bomber to cradle the Parasite fighter. Once over enemy territory, the mini escort could take off and deal with any approaching enemy interceptors. Though an impressive theoretical concept, this Mistel was too radical an idea to put into practice. It never went past the planning phase. Well before the planned launch of Operation Iron Hammer, the Battle of the Bridges had already begun. As the red tide surged towards Berlin, Germany's last natural river barrier, the Oder, was about to fall. March 1st, Russian forces moved inexorably westward. To stall any advance towards Berlin, the bridges over the Oder had to be destroyed.
The targets specifically were the stone and masonry of the support structures on which the iron girders sat. And if they could hit those and the hollow charge warhead could push its way in to the masonry of the support structures below the iron girders, bridge would collapse.
Repeated Mistel attacks had proven unsuccessful with just one near miss recorded. In the west, General Patton's Third Army experienced a Mistel attack for the first time. On March 25th, the pontoon bridges near Oppenheim were targeted. That night, 4 Mistels led by 5 Pathfinders took off. Anti-aircraft fire disrupted the attack, and no hits were recorded. One of the most successful Mistel attacks of the war occurred on March 31st. 6 Mistels were assigned to attack the rail bridge at Steinau over the Bova River. Unfortunately for the Germans, just 3 Mistels reached the target. According to the surviving pilots, the bridge was hit 3 times, but this has never been confirmed. Throughout April, the Mistel attacks continued, but with little to show for it. Allied bombing and strafing destroyed many Mistels on the ground. Weather, poor training, and mechanical failures soon proved overwhelming. Missions that launched with 4 or 6 aircraft often ended with just 1 or 2 actually reaching their target. None of the bridges targeted over the Oder or Vistula rivers were destroyed. It was an exercise in futility. On April 31st, the last Mistel attack of the war was launched. May 1st, 1945. British forces under Field Marshal Montgomery race across northern Germany, advancing from the Elbe towards Berlin. In bitter house-to-house fighting, Soviet forces slowly reduced the Nazi capital to rubble. Hitler's suicide soon follows. On May 7th, Mistel operations officially cease. For the pilots and ground crew, the march westwards towards the Elbe is their only hope of capture by British and American forces. The Mistel's short operational career was a complete failure. Never considered a wonder weapon like the Me-262, V-1 Buzzbomb, or the V-2 ballistic missile. It was, however, a workable low-tech answer to a very specific problem. As a weapon system, it was relatively easy to master. Both aircraft flew without any serious vices. The aiming process was straightforward and easy to master.
Remarkably, as far as is known, only a few Mistel pilots were lost in these missions. What is remarkable is actually, of the small number of Mistel, we're talking 20, 30 at the most. Okay, they may not have hit the bridge, but the Mistel certainly fell near the target. Separation was effected efficiently, and the pilots got back to base. And it's a remarkable testimony, again, to the mechanics of the Mistel and to the pilot's skill.
Fortunately for the Allies, Mistel units couldn't launch more than 6 to 8 at a time. Most missions were flown at 9, and Allied air defenses were extensive, making any success highly unlikely. By 1944-45, the Mistel was in many ways a great waste of resources. The warhead alone accounted for 1,700 kilograms of explosives, material that was vitally needed in the production of artillery shells. Huge amounts of aviation fuel were allocated to Mistel units, robbing fighter squadrons of vital supplies needed for air defense. In the end, for all the effort, training and resources allocated, the returns were negligible. Still, the Mistel crews never lost faith in this unusual weapon.
When I met and interviewed a number of Mistel pilots in the late 1990s, one thing that struck me was the faith they had in that weapon. The faith in its technological abilities, but the faith they had in the ability of the weapon to hit its target, and their faith in the ability to destroy a target. I never was left with any impression that they did not believe in that weapon. And these were very experienced instructor and former bomber pilots.
One can only imagine what might have happened if the Mistel had appeared in 1942. British surface ships and convoys in the Mediterranean would have been devastated. Malta might very well have fallen, making an Allied victory in North Africa that much harder. The war would certainly have lasted longer, but the outcome would have been the same. The appearance of the Mistel was one of the great oddities of World War II. It was like the V weapons and jet fighter, a case of too little, too late.
When Germany first went to war with its attack on Poland, she had relatively conventional aircraft. Her fighters, bombers, and transports all had counterparts in other air forces, although the Luftwaffe generally was numerically superior. Whilst most nations were trying to avoid conflict, Germany was consumed by a burning need to embrace war as a matter of honor. On the other hand, at secret test centers deep inside the fatherland, the Reich's best scientists and engineers were thinking about concepts quantum leaps ahead of all those in other nations, testing every type of innovation far beyond the pale of normal expectations. This produced a mixture of outright failure and unprecedented success. Often surrounded in half-truths, the results became an amazing broth of myth and reality. Germany's incredible miniature fighter competition, however, was no myth. It was a reality that did take place, and the results were marveled at long after the Second World War was over. During the final stages of World War II, Germany, in desperation, rushed to exploit its staggering developments in jet engines, rocket motors, and aerodynamics to maximum advantage. At first, they attempted to create advanced war-winning aircraft, but as time grew more desperate, they hoped to manufacture cheaper aircraft in massive enough numbers to push back the Allies. It was when Germany was on her knees that the miniature fighter competition was born. Germany had been able to produce fighters and bombers powered by jets and rockets. Both types proved their worth with unqualified success whenever they went into frontline service. Unfortunately for the Luftwaffe, they were too few and arrived much too late. The Messerschmitt 262 was without a doubt the best fighter aircraft of the entire Second World War, and beyond. Such was Germany's technological advantage.
The Me-262 was the most formidable aircraft of World War II. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance.
By way of further innovation, the Walther liquid-fueled rocket motor was able to propel the Messerschmitt 163 Comet point defense interceptor to higher speeds than any other aircraft of the war, including all the jets.
The Comet was definitely the most spectacular aircraft of the Second World War. It was extremely fast, extremely remarkable as far as the technology behind it.
These by no means were Germany's only innovations. There was also the least sophisticated of Germany's new power plants, the Argus Pulsejet, a rudimentary but effective and economical device which powered the infamous V-1 flying bomb. Perhaps it could have tipped the war in the Nazis' favor had it been employed sooner. As the war ground on to its final stage, 3 radical German fighter projects were rushed into development, and some even onto production. They were the emergency fighter, the people's fighter, and finally, the miniature fighter. Incredibly, despite all the shortages that arise when losing a war, each of the successful aircraft were a product of vigorous competitions between competing designers. Or at least, that's how it was supposed to work. Contracts for aircraft development were issued and managed by the German Air Ministry, known as RLM. In mid-1944, the RLM's priorities were to make the most of the nation's crippled aviation industry, and to defend the fatherland from almost certain annihilation. Having no other choice, they were obliged to rely upon the mere remnants of a once great production machine, hoping to produce results that just might save their nation. Many new designs were based around the Heinkel HES 011, Germany's most ambitious jet engine. One that was never ready, even by war's end, although a prototype had been assembled. It was hoped that the awesome power of Heinkel's engine would help propel the winner of the emergency fighter competition to victory.
The emergency fighter program. Basically, this called for an airplane to be built within a certain set of parameters. Number one, it had to be jet-powered. Number two, it had to be extremely high performance for its day, and that was with max speed of over 600 miles per hour. And number three, it had to have a minimum range of about 800 to 1,000 miles.
The RLM was looking to develop an extremely advanced interceptor, one capable of downing the expected American B-29 Superfortress, the most advanced bomber of its time, and one capable of reaching heights never previously even contemplated. The Focke-Wulf TA-183, sometimes called the Huckabine, would have been the ultimate jet interceptor, perhaps even for some years to come. The design, together with its equally advanced weaponry and Heinkel's engine, employed every scrap of new technology available, all of which were exclusive to the Third Reich. The company bested a competitive design in the Junkers EF-128, although by a narrow margin. Either of these outstanding concepts would have simply staggered any Allied designer on first sight. The level of advanced aerodynamics employed in both instances would have been quite mind-boggling. Had they been on hand just a few months earlier, they would have been a difference maker. Unlike the Messerschmitt 262, the emergency fighter was to have a single jet engine only, and was based around the yet-to-be-delivered HES-011 jet engine. An earlier Jumo 004 type filled in as a substitute. Although either combination would likely have had a significant impact against the expected fleets of American B-29s had they had actually been employed against the Reich. However, the TA-183 was never completely finished, falling into British Army hands just before Germany's surrender. As a consequence, Focke-Wulf's ingenious interceptor never rose into the air. Although it's more than possible, it may not have been needed anyway. Poetically, the much-feared American superfortress was never actually intended for European use, and the one time an example did fly into Britain, it was merely a ploy to divert Germany's efforts into projects such as the Huckabee. It was a ruse that clearly worked. A further reflection of the fast deteriorating state of Germany's war fortunes was the People's Fighter. The Reich was showing clear signs of a diminishing supply of both traditional materials and pilots. With dwindling numbers of airmen, could the Nazis rely on German boys to man their cockpits? Some in the party were seriously considering this idea.
They were planning to use teenagers out of Hitler Youth or out of a National Socialist Flying Corps, which at least had some basic training on gliders, put them on single-seat jet fighters and hope for the best.
Even if the Germans had succeeded in building a schoolboy air force, there was still the question of building new aircraft with what few factories and materials were left. To keep airplanes rolling off the assembly line, another source of human energy would definitely be pressed into service. And by no means for the first time.
By the end of the war in Germany, a lot of the workers in the armament industry were not there voluntarily. They were forced laborers, slave laborers. You're looking at the V2 rocket, you're looking at the Messerschmitt 262, you're looking at the Comet, you're looking at the 162 as well. There was a lot of people with little enthusiasm, which raised the risk of sabotage.
Dr. Richard Vogt of the Blom & Voss Company had long been aware of the shortages of imported metals such as aluminum. He had often experimented with tubes made of steel, as iron was still in abundance. Vogt's entry into the People's Fighter competition, the BV-211, consisted primarily of two steel tubes welded together in an overlapping position. All the other components were simply bolted to this strong and effective frame.
Vogt, with his brilliant engineering ideas, he could see that the aeroplane needed to be mass-produced, and he designed it in such a way that it could be mass-produced, almost like a model aeroplane kit. Various parts could be farmed out to unskilled people and all brought together and bolted together, the fuselage being a tubular affair, with the aeroplane just simply built around it.
Ernst Heinkel wasn't running his company at the time of the competition. In fact, it had more or less become the personal property of Hermann Göring. Still, a highly advanced lightweight aircraft did emerge from his factory in the form of the HE-162. Built largely out of wood with a jet engine mounted aloft, it was a clever concept, and when it won the RLM competition, it proved effective. However, it is likely that the alternative Blom & Voss design would have been the better aircraft, and that the contract may have gone to the Heinkel Company as a favor to the Vice Fuhrer. Built largely with slave labor, the Sparrow, as it was named, was a sophisticated aircraft, probably too much so to be placed in the hands of less than enthusiastic slave laborers. Detailed work with the world's most advanced technology was not best achieved under the lash.
The Heinkel 162, it was a nice idea, but whether or not they would have been able to put them in service in 1945, you need the pilots, you need the fuel, you need the time to actually train everyone, the ground crews, etc. They were running out of time.
The final fighter program was by far the most desperate and bizarre of all. It was the miniature fighter competition. Almost as the war was coming to an end, the German Air Ministry identified a requirement for the cheapest fighter possible. These aircraft would have to be diminutive to the extreme, a pygmy amongst other types. And the concept actually had some precedence. By the time of the competition, Germany had already created a substantial list of tiny aircraft for highly specialized missions. Long before the RLM search for a miniature fighter, there had been numerous attempts to use solid-fuel rockets to propel very light aircraft. The Opel RAK-3 rocket-powered glider is perhaps most well known. Its fuel was just black powder packed tightly in a number of canisters and ignited all at one time. As comic as these attempts might seem, they led the way to more ambitious exploits. Other types of rocket-powered aircraft started to appear, mostly in the hands of hobbyists, sometimes with wealthy sponsors. However, this interesting pastime started to get somewhat out of hand, and the Nazi Party stepped in to get things under control.
At that time, Germany decided rocketry would now become a state secret. All amateur rocket experimentation would be now outlawed. It would be against the law to shoot off a rocket just for pleasure or for experimentation.
Of course, the Nazis themselves never lost interest at all. Rather, they saw great potential in what was fast becoming a science, especially as more advanced chemical fuels were being developed. Within a few years, there were two types of liquid-fueled rocket motors available. Firstly, there were the A1s and 2s developed by von Braun, stepping stones to his infamous A4 ballistic missile. It was fueled with a mixture of alcohol and liquid oxygen. The other was the Walther, chemically fueled rocket. This used hydrogen peroxide, pumped under pressure to mix with a reactant, which produced a tremendous, not to mention highly dangerous, thrust. In 1939, Professor Heinkel designed the HE-176, a small aircraft that was really little more than a glider powered by a small von Braun motor. However, it was this prototype that actually made the first liquid-powered rocket flight. It has to be said that von Braun himself had previously put forward a similar type, which was to be fired vertically from a ground installation, like a missile. The project was never completed, as at the time, the RLM considered both offerings too advanced to be of any great use to the war effort, although they were not entirely forgotten. The other type of cheap, yet rather clever aircraft power came in the form of the Argus Pulsejet. A primitive device, to be sure, although one that seemingly came out of nowhere when it put dread in the hearts of people throughout southern England. It had enough power to propel a small yet deadly projectile, the V-1 flying bomb. Looking like little more than a large stovepipe, the Pulsejet emitted a hated low-pitched rumble which preceded a terrible explosion, from which there appeared to be no escape.
The V-1 had about a 1-ton high-explosive warhead, and when it hit the ground, it would explode with tremendous force. Sometimes the V-1 would create a crater 1,000 feet wide, sometimes 2,000 feet wide. A pulse jet engine is a stovepipe. Air comes in, there's a small grid where it's compressed, and fuel then is pushed into this grid via air bottles. And then there's an ignition. It stops for a nanosecond or two, and then air comes in, compressed again, and it explodes and provides thrust. And so that's why the pulse jet engine was called a doodlebug, a buzz bomb, and when it flew, it went pop, 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 pop.
The device had just one Achilles heel. The problem with the Nazi flying bomb was it needed to be launched at speed, either from a powered ramp or an aircraft in flight. Given that the V-1 resembled a cruciform aircraft in every way, it's of little surprise that a piloted version should at least be tested, and so several of the type were modified into piloted aircraft. Courtesy of famed German aviatrix Hannah Reich, the main aerodynamic failings of the FS-103, as it was properly named, were at least improved upon.
The V-1, as they fired it off the catapult ramp, it was rolling over onto its back. And Hannah said that if they put controls in, she would fly it. She was the only person that could. She was tiny, 5 feet 2, and could get into this cockpit. She flew it, obviously a very high-risk affair, discovered the problem, and of course they were satisfied with that, but Hannah wasn't. She said, no, I want you to modify it, and then I'll fly it again and see that it really is the answer, which she did. Now, the second time round, they made a slight error. They didn't leave enough fuel, and she ran out of fuel and landed on the dunes on the Dutch coast and was quite badly injured. But she had made her name.
Even with her input, the main problem arising from the constant vibration of the Pulsejet, which was so close to the pilot's cockpit, was never solved. And so Germany's buzz bomb miniature fighter, the Fiesler 103, was abandoned. Still, the sheer economics of making the Argus Pulsejet insisted that it be considered for other uses, and so it was. The Pulsejet motor was tested with aircraft as diverse as unpowered troop-carrying gliders to advanced trainers and high-powered night fighters. So much was learned, although where that knowledge would be ultimately applied was unclear. Curiously, there was one inexpensive pint-sized Homeland Defender that may have proved even more economical. This one didn't have an engine of any kind. It was simply a glider, but a glider with a unique job. Again, designed by Richard Vogt, this glider was especially designed to ram incoming enemy aircraft, in particular U.S. daytime bombers, and to hack off their tail sections. To protect the German pilots from the force of the collision, they were enclosed and protected in a hardened-prone cockpit. After having first been towed by fighters to a position above the enemy bombers, the BV-70 swooped down on their prey. Their diminutive size gave them an edge, as they were a tiny target for U.S. gunners to lock on. The same fighters would attempt to stay on as glider escorts, at least until Mustangs arrived. The concept may have seemed bizarre, although about the same time, Northrop and America were testing aircraft for exactly the same purpose. Another genuine miniature fighter which predated the official RLM competition was the Messerschmitt Me-328. The type's original role was that of a Parasite plane, to be carried by the America bombers on long-range missions to attack the U.S. There were two versions of the Me-328, one being a fighter and the other a very small bomber. And there is some doubt whether, as an America bomber Parasite, it would have served in one or both roles. In any event, this ambitious plan to attack the U.S. was abandoned by the middle of the war. Power plants for the 328 varied from two Argus pulse jets to a Volta rocket motor, to a Jumo 004 turbojet. It couldn't, however, have carried too heavy an engine, given its wooden construction. It is known that Hannah Reich flew the Me-328 when it was in a Parasite configuration on top of a Dornier 217, although the exact purpose of this experiment has never been explained. A number of innovative miniature fighters were conceived to defend Germany's key industrial and military sites. By the middle of 1944, the Luftwaffe was looking for a purpose-designed target defense fighter. This need caused some to reflect on von Braun's point defense rocket fighter of 4 years earlier.
In 1939 and again in 1941, von Braun submitted a proposal for a vertical takeoff rocket plane. He argued that the most important thing for a fighter was to be able to reach altitude as quickly as possible and to engage the enemy immediately. Conventional aircraft required an airfield to take off and then had to search for the enemy. Von Braun's rocket-powered plane would take off vertically, possibly from a mobile launcher, and then follow a radio beam up to the vicinity of the target aircraft. It was only at the last stage, when the interceptor was about to engage the enemy, that the pilot took control.
It was only a concept, of course. However, von Braun's reputation had grown since then, and now a previously disinterested Luftwaffe was actually asking for a vertically fired rocket fighter. Heinkel was commissioned to produce a ramp-launched fighter, which was to be known as the Julia. It was mainly powered by the Volta rocket motor and assisted in takeoff by 4 solid-fuel rockets. However, a few months into the project, Heinkel also chose to develop the basic design into something closer to the short takeoff Comet, a move that has never really been explained. As ambitious as the Julia and von Braun's aircraft were, there was an even more advanced rocket-powered miniature fighter in the works, supported by one of the most notorious Nazis. Germany started World War II on the offensive, snatching up most of Europe in blitzkrieg style. But as the Allies regrouped, she soon found herself playing defense, protecting herself from the waves of bombers burning down her cities and destroying her industry. Outnumbered and with dwindling resources, Germany's designers relied on their resourcefulness to create new breeds of miniature fighters. Without a doubt, the most ambitious of all German miniature aircraft conceived during the war was the Bacham Natter. This true vertical takeoff point defense fighter was one of the most complicated designs ever to fly, however briefly. The Natter was unique even amongst other unusual aircraft. Firstly, it was never actually commissioned by the RLM. It was an idea they had declined earlier. The project was adopted unilaterally by the infamous head of the SS, Heinrich Himmler.
It was clear that Himmler wanted to take the Natter under his control. At this stage, Himmler's power was in the ascendancy. He wanted the SS to take over armament development. Himmler offered to support Bacham, and Bacham accepted.
It was Himmler who authorized all the costs and even the building of the factory where the aircraft were to be assembled, as well as the actual construction of the individual aircraft, albeit under qualified supervision. The Natter would have been a true point defense fighter, much like another German rocket craft of the time, the Me-163 Comet. Its job was to defend specific targets critical to the war effort, although in many ways, the Natter could be seen as an answer to accuracy problems with earlier German missilery. With the Natter, a pilot could launch large numbers of missiles close to the enemy with great accuracy. Bacham's invention was perhaps more of a missile carrier. Though the Comet and Natter were both point defense fighters and used Walter rocket engine power plants, that's where the similarities ended. The Comet made a quick horizontal run before going almost vertical. The Natter, on the other hand, was simply fired on a ramp that was aimed in a totally vertical position. Due to the additional power needed to launch in a vertical position, similar to the Julia, 4 extra detachable solid-fueled rockets were added. Comets were particularly vulnerable to Allied fighters on takeoff and even more so on landing. For this reason, the Bacham Natter's vertical takeoff ramp was designed such that it might be hidden in a wooded area, in the same way certain V-2 missiles were. Apart from its potential for clandestine takeoffs, a major reason for Himmler pursuing what was really a private venture was the Natter's weapons payload. The nose section was filled with the A6M folding fin air-to-air rockets, fired in a salvo. There was simply no possible antidote for these terrible, deadly weapons.
The R-4M rocket missiles, when they struck a bomber, it wasn't a question of damaging it or downing it, it was a question of disintegrating the entire thing.
Allied concerns about the effectiveness of the A6M were such that advancing ground armies were under special orders to capture and destroy these weapons at all costs. Takeoff and attack were a precarious enough procedure for pilots, but descent was no easier.
The Natter for me is utterly fascinating. It was designed in such a way that it would actually come apart in flight after its engine had cut. At a certain height, the pilot was able to get out of the front part on his own and come down with a conventional parachute. The engines would come down by its own parachute. What that did was ensure that the whole thing could be reused, man and machine. And the interesting parallel that I draw is really it's the precursor of the space shuttle concept. You have a crew, you have an aircraft, it goes up, it does a job, but it comes back to Earth again and can be reused. And it's ahead of its time.
There were 36 Natters completed, although many were used as gliders to test the type's handling properties in the post-attack glide situation. There was only ever one attempt at a manned launch, and that resulted in the death of its young pilot. The designer, Erich Bacham, always claimed he never saw the Natter as a suicide mission. However, the risks of flying such a complicated machine were self-evident, and probably why the RLM declined and Himmler did not. Early in the war, de Havilland had developed its iconic Mosquito twin-engine fighter-bomber. The type's performance was greatly respected by the Luftwaffe, especially as a night fighter. Knowing the Mosquito's secret was its strong wooden construction, the RLM sought to emulate the British success by using similar techniques in the construction of a miniature fighter. The secret involved pressing 2 types of wood laced with a patented adhesive in an autoclave. Wood was in abundance in Germany, and the German chemical company Goldsmith made a product called Tego film, which would be a good bonding agent. All went well, and Focke-Wulf produced its model TA-154 now named Mosquito, mimicking its RAF competitor's moniker. By now, the Luftwaffe had little choice but to rely increasingly on wood, so the Tego film process was used extensively. Then, one night in February 1943, RAF Bomber Command struck the town of Wuppertal and destroyed Goldsmith's only Tego film factory. In one of the war's examples of poetic justice, the bombing mission was guided to its target by a de Havilland Mosquito. However, by now, Germany's reliance on wood for aircraft construction was locked in, and therefore a substitute resin had to be found, and indeed it was. Not that far away in Leverkusen, the Dynamite Company produced a cold adhesive which was known as an ersatz, or wartime substitute product, and it was available. Focke-Wulf continued production of their Tu-154 using this new adhesive. Slowly, a few of the new German night fighters started to go into service. After a few months of flying, a wing broke off a later production model.
Tank actually took the action of grounding the 154s because the glue was coming unstuck. The stuff he had used earlier on was this very good adhesive, which was totally eradicated when the factory was bombed out of existence. And the new type of glue they had was not up to that grade and was actually coming unstuck, and they had a couple of crashes.
In November of 1944, the Luftwaffe High Command asked the RLM to issue a request for an extremely economical, very light fighter. Their specifications were dictated by two simple facts on hand. Firstly, jet engines were constructed of hard-to-come-by materials, and the Argus stovepipe was not. Secondly, an Argus Pulsejet had powered the Me-328, which had flown quite successfully, and was likely the cheapest powered aircraft ever produced by the RLM. Following years of miniature fighter development, the actual miniature fighter program was a very short-lived event. The required specifications were so frugal that few manufacturers even bothered to respond. The power source was to be the Argus 014 Pulsejet, and construction was to be mainly of wood. There was also to be an absolute minimal use of instrumentation. This bare-bones aircraft would be less sophisticated than many basic gliders. The initial speed necessary to fire the Argus engine could be achieved by catapult, solid-fueled rockets, or towing. Either way, it was expected that literally hundreds of the types selected could be produced and used to beat back attacking Allied bombers by sheer weight of numbers. Although a selection program was undertaken, it quickly boiled down to just three contenders: Heinkel, Blom-Voss, and Junkers. The Heinkel offering was the least difficult to achieve, although it probably didn't fulfill all of the criteria for a miniature fighter. It would require very little development. The company's designers merely had to take the existing 162 Salamanders, strip it of its BMW 003 turbojet, and replace the most valuable power plant with one or possibly two Argus Pulsejets. Of course, there would have been a very considerable saving in cost and weight, but would the radically diminished end result have justified the effort? Possibly yes. As it was, there was no way that BMW could supply anything like the number of 003 jet engines needed, due to the raw materials being in such short supply. On the other hand, the airframe was a product of wood and slave labor, ingredients that Himmler's SS could always seem to find. However, the absence of the reliable Tego film bonding agent meant that the Salamander was doomed to suffer the same fate as the German Mosquito. Rather, like the fatherland, they were starting to fall apart. The second competitor in the miniature fighter competition, Blom & Voss, had built some of the world's largest flying boats, mammoth six-engine aircraft, and now they were being asked to design a flea driven by a stovepipe. But loyalty prevailed and great minds took up the cause. Their design never left the drawing board, however. It still reflected the company's desire for uniqueness and the brilliant mind of Dr. Richard Vogt. The BVP-213 likely would have done everything asked of it, although Vogt had chosen to use more metal than requested. He always wanted his aircraft stronger. Had his People's Fighter with tubular steel design been chosen, then the Luftwaffe might not have been left with a fleet of disintegrating salamanders. The third competitor, the Junkers EF-126 Ellie, was probably more like what the RLM had expected. However, as the war had reached its final stage and the Reich was in its death throes, major services stopped and nothing was working anymore. As a result, all that Junkers had to show for their effort was a full-size wooden mock-up and the plans, together with some wind tunnel test results. And then, the RLM quickly cancelled the whole program at the end of December 1944. Even so, it's known that some calculations were still taking place in late March of 1945, just before the Soviets arrived. The Allies were anxious to snap up any scientists and technology left behind by the Reich. The great strides they had made in aerodynamics and in engine technology were assimilated into aircraft of the Cold War. Similarly, small-scale designs as those of the miniature fighter competition were toyed with and tested. The Soviets hit the miniature fighter jackpot at the Junkers plant in Dessau. There they found the wooden mock-up of the EF-126 and Junkers' best pilots and brightest designers and test pilots. They were even handed the manufacturing plans for the aircraft. The Soviets were particularly eager to develop jet aircraft of any type and quickly ordered prototypes constructed. Early glider tests were a deadly operation for even the best of Germany's test pilots. The Soviets had better luck rekindling old German technology when launching powered EF-126 from old German bombers. Though the tests were for the most part satisfactory, the Pulsejet fighter idea didn't take off. The Soviets had the resources to build faster, more sophisticated jet fighters which outmatched their tiny German copies in most every way, other than cost. In 1951, Britain launched their own miniature fighter, the Fairey FD-1. About 26 feet long with a wingspan of 19 feet and with a fully loaded weight of 6,800 pounds, it certainly was as tiny as some of its German predecessors. The hopes of a nation did not rest on the Fairey Delta's shoulders, though. This was a research aircraft to see how Delta wings responded at transonic speeds. Taxi tests began in May of 1950, and on March 12, 1951, it was ready for its maiden flight, piloted by Group Captain Gordon Slade. Unfortunately, the aircraft had serious and dangerous stability problems, and the problems could not be resolved with additional modifications. Though 2 more airframes had been ordered, the program was ultimately cancelled. The lone Fairey FD-1 continued to provide research data for future Delta Wing projects like the FD-2 and Concorde. The Americans first dabbled with miniature fighters during the war. In 1941, Bell Aircraft took up the U.S. Army Air Force's challenge of building a small, lightweight fighter using non-strategic materials. Like Germany's miniature fighters, the XP-77 was largely made of wood. It was a low-wing monoplane fighter, armed with a 20mm Hispano cannon fired through the prop hub, 2 half-inch Browning machine guns, and optionally, a bomb or depth charge. The project was plagued with problems from the get-go. Its 500 horsepower supercharged Ranger engine wasn't ready on time, and the aircraft was overweight. Underpowered and heavy, the XP-77 was difficult to fly. The Americans also had concerns about the glue used to bind the wooden aircraft. a problem the Germans experienced with their Mosquito and Salamander. The XP-77 project became less and less of a priority for Bell and the USAAF, and by 1944, it fizzled out completely. However, it wouldn't be long before McDonnell Douglas conjured up a new mini-fighter for the USAF, the Goblin. World War II ended with America becoming a nuclear power. It had successfully dropped atomic bombs on Japan from B-29 bombers. At the time, Japan had few interceptors capable of reaching the high-flying pressurized bombers. But with the dawn of the jet age and Cold War, all that would change. Jet-powered interceptors would be able to thwart an American nuclear assault against a Cold War target. The problem was no American escort fighters were available with the range and altitude to keep up with her bombers. But what if an aircraft could be made small enough to fit on board an American bomber? The McDonnell XF-85 Goblin was designed just for that purpose. At only 14 feet long with foldable wings, it was small enough to fit in the belly of a B-36 bomber. It was similar in concept to Germany's combination of an America bomber with an Me-328 Parasite plane. Testing began on a specially modified B-29 in 1948. The aircraft was launched from a hand-light crane in the belly of the aircraft. Once released, the pilot could take on any incoming interceptors. When the hostiles were cleared from the sky, it was time for the Goblin's toughest assignment, getting back into the bomber's belly. Turbulence made this a challenge, and during the first test, McDonnell test pilot Edwin Schoch crashed into the crane and plummeted back to the ground. He was, however, able to make an emergency belly landing and save the Goblin and his own life. Though the aircraft was repaired and refinements were made, the program was cancelled. The Goblin would not be a match for the new Soviet interceptors it might tangle with on the way to target. As well, the development of air-to-air refueling meant that conventional jet fighters could serve as escorts. The miniature fighter competition was born from the desperation of a country on the brink of defeat with limited resources and an ample supply of imagination. Imagination that spawned a slew of other diminutive fighters throughout World War II designed for highly specialized missions. Some concepts were more successful than others, as Germany took a kind of shotgun approach in an attempt to create war-winning designs. In the end, as resourceful as the Germans were, they lacked the resources and manpower to reverse their fortunes.
As far as aviation in the Second World War, as far as aerodynamics, now the Germans were extremely advanced. There's no doubt about that. The swept wing, for example, was certainly the idea. Rocketry, certainly very advanced in that regard. But they didn't have the resources. They didn't have the time. They were not focused. A number of people tend to think of Nazi Germany as a monolith because you have a dictatorship, you have a clear line of command, you decide, you do it. If you don't do it, well, you pay for it. It was quite different. It was a polyarchy. It was complete chaos. It was a 15-ring circus. You had people doing all sorts of things, going in every direction. The Luftwaffe was like that. The army was like that. Weapons development was like that. It was complete mayhem.
A handful of miniature fighters were experimented with after the war, and although they did provide research data, they could not outperform larger conventional aircraft of the day. In the end, the miniature fighters are an interesting footnote in aviation history. They had little impact on the outcome of the war, other than to drain some of Germany's resources. How can we raise up a giant? How do we give birth to a jungle warrior? How do we craft an airplane to take us around the world? Designers seeking to answer this strange mix of questions all came up with the same answer: twin booms. From the legendary Lockheed Lightning, to the de Havilland Vampire, to the Fairchild Pack Plane, designers have turned to twin booms to meet some of the toughest challenges. Though their quirky looks raised some eyebrows, more often than not, the boomers of aviation proved to be works of genius. Even without its twin-tail booms, the Kalinin K-7 is arguably one of the oddest-looking aircraft ever constructed. Designed by Soviet World War I pilot Konstantin Kalinin, it was quite Frankenstein in appearance, with 7 engines bolted onto the wings and with 2 massive underwing pods. The pods housed the landing gear and were armed with machine gun turrets. It was a bold piece of engineering. The K-7's gigantic wings spread almost as far as B-52s, and it could carry 128 passengers, 150 fully armed paratroopers, or 21,000 pounds of bombs. Unfortunately for the Soviets, their pride in homemade products may have been their downfall. Kalinin had planned to use BMW engines, but a switch was made to Soviet AM-34 engines. They were badly underpowered, and a 7th pusher engine was added between the tail booms as a booster. The K-7's diminutive twin tail may have been chosen as a way of keeping total weight down. However, the twin booms turned out to be the K-7's Achilles heel. On its final flight, the tail boom began to shudder and fell to pieces. The flying giant went into a deadly dive. 14 passengers and 1 bystander on the ground were killed. It was a PR nightmare for the Soviets, who had bragged about the creation of a totally Soviet-made monster aircraft. The twin boom design also helped to get a flying shoe into the air. The BV-138 was a twin boom amphibian aircraft built by German manufacturer Blohm & Voss. Seaplanes have to deal with a problem known as sticking, or the tendency of the hull to stick to the water during takeoff. Certainly, the BV-138's trimotors and rocket pods would have partially alleviated this issue. However, the designers at Blohm & Voss went one step further. They decided to give their seaplane a high twin-boom tail. The tail sat well above the waterline, meaning there was less hull surface area to stick to the water during takeoff. The shoe-like appearance of the clipped tailless fuselage earned this aircraft the nickname of Der Fliegende Holzschuh, or the Flying Clog. At first, the shoe was a good fit for Germany. At the start of World War II, it was the main maritime patrol and naval reconnaissance aircraft of the Luftwaffe. Later versions were equipped with a dural hoop for minesweeping. Perhaps the most notable achievement of the BV-138 was that it was also able to outduel another legendary seaplane in a dogfight, the consolidated Catalina. Though the shoe was an old favorite in the Luftwaffe, it soon became unfashionable. With the arrival of Allied carriers and more advanced fighters, the other shoe dropped, and the BV-138 was outmatched and obsolete. Twin booms could also provide an aircraft with a $1 million view. The Abrams P-1 Explorer was designed by Talbot Adams specifically for aerial photography and mapping. The P-1's twin booms allowed Talbot to place the engine at the rear of the fuselage. This kept the camera free from oil and also improved forward visibility. The cockpit was pushed well ahead of the wings and was walled with framed plexiglass, giving the pilot and crew an unobstructed view of all ahead and below. Talbot continued to tinker with the design in the hopes that the plane might snare a buyer and become mass-produced. But when war arrived, all those plans were put on hold. In World War II, reconnaissance aircraft were just as vital to operations as bombers and fighters. They could gather tactical recon about the movements and defenses of enemy forces, assess bomb damage, and help pinpoint the positions of enemy targets in the battlefield. In 1937, Germany was looking for a 3-seat recon aircraft to help support ground operations. Arado offered up the AR-198, a conventional aircraft with windows in all directions to ensure good visibility. From Blom and Voss came Dr. Richard Vought's daring asymmetrical plane, the BV-141. Legendary Focke-Wulf designer Kurt Tank gambled on a twin-boom design when he conceived the FW-189. Like the Abrams Explorer, the aircraft's twin booms provided for a clearer view of operations below. A central crew gondola, walled with windows, and virtually sitting on top of the wings, offered an excellent view in all directions. Tonk jeopardized the proposal by insisting on 2 engines rather than 1, but in the end, the FW-189 won the competition, and officially became Germany's eye in the sky. In all, 864 aircraft were produced in factories in Czechoslovakia and occupied France. The aircraft was particularly effective on the Russian front, where it gained the nickname the Rama, or frame, for the rectangular shape formed by the wing, tailplane, and booms. Russian fighters more often than not found themselves firing through the frame and hitting nothing but air. The FW-189, though not the quickest of aircraft, could outturn Russian fighters and blast them from behind with its machine guns. Visibility was also a paramount feature for night fighters searching for prey in dark hostile skies. It's not so surprising that the Americans chose a twin-boom design when they hatched the P-61 Black Widow. In 1940, Britain was looking for a night fighter of its own. The Luftwaffe's bombers were tormenting London, sneaking in under the cover of darkness. The RAF needed a high-altitude aircraft that could stand guard over London through the night to repel these invaders. Experiments were already underway with a new key piece of night fighter technology, AI, or airborne radar. Radar would make a fighter a deadly nocturnal predator, able to pick out enemy aircraft in pitch darkness. A cash-strapped Britain shared the secrets of radar to U.S. manufacturers in the hopes of earning back royalties. Radar was the missing ingredient designer Jack Northrop needed to set loose his own deadly spider. His P-61 Black Widow was in many ways reminiscent of the FW-189. Both had twin booms, twin engines, and a central gondola with an excellent view in all directions. It was America's first aircraft to be installed with radar from the start. Like a spider sensing vibrations in its web, the Black Widow could detect enemy aircraft with the help of the radar unit housed in its rounded, protruding nose. Unlike the FW-189, the Black Widow was designed to be a killer, and its twin-boom design made it a crack shot. Originally, Black Widow carried 4 belly-mounted 20mm forward-firing cannons. Placing the guns in the center line made for more accurate shooting. Some variants also included 4 remote-controlled 50mm machine guns. The Widow could essentially strike approaching enemy aircraft coming from any direction in the upper hemisphere. A byproduct of its gun placement was more room in the wings for fuel storage. This was a critical feature, as the P-61 was designed to loiter for hours at a time. Many innovative features were packed into the Black Widow's fuselage. When asked about the twin-boom arrangement, Gerald H. Balzer, a former Northrop engineer, said, "The configuration of an airplane depends on what you want to cram into it." The P-61 arrived a little late in the war to have a significant impact, but there were other twin-boom fighters in the air causing mayhem for their opponents, including the Fork-tailed Devil. One of the great strengths of the twin-boom design is the ability to place guns in the nose of a fighter without penalty. In World War I, the riddle of firing through a propeller without blowing it to pieces was solved with the invention of interrupter gears. In World War II, although it would have been theoretically possible to incorporate this same technology in some of the single-prop fighters of the day, there were the problems of additional weight and interrupter gears slowing the rate of fire. Fighters like the Spitfire and Mustang placed their weapons on their wings to avoid this issue altogether. Their guns were angled so the bullets would converge at a set distance in front of the aircraft. This, however, created another problem.
A pilot had to wait till an enemy aircraft was a perfect distance away to ensure a good hit. This added a level of complexity to an already frenetic dogfight, which could lead to fatal results in the hands of less skilled pilots. Fighter pilots flying twin-boomed aircraft like the P-38 did not have to worry about conversions.
The reason the P-38 was so awesome in its firepower is because the guns were in the nose. When you fired 450s and 120 and it went straight out. And all the other fighters in World War II, the guns are out in the wings. So the fire goes, and right here is the only place that has maximum impact. The P-38's maximum impact all the way.
The Fokker G-1 was World War II's original twin-boom fighter. It first flew in 1937, but it did not see combat until May of 1940. Nicknamed Le Faucheur, or Reaper, it was designed to wreak destruction. This twin-engine heavy fighter had a potent arsenal of weapons to clear enemy aircraft from the skies and gain air superiority. There were two 23mm cannons and up to 8 7.9mm machine guns in the nose. One machine gun was installed in the rear-facing turret to deal with any invaders sneaking up from behind. Dutch aircraft manufacturer Fokker received an order of 26 G-1s from an enthusiastic Spanish Republican government, but the aircraft were never delivered. Though the Spanish paid for the Reapers, there was a Dutch embargo on the sale of military aircraft to Spain. Fokker, however, continued building the aircraft and issued a false press release that the fighters were for Finland. The G-1s didn't see any combat until the Dutch were literally fighting for their lives. On the 10th of May 1940, Nazi Germany invaded the Netherlands. The Dutch threw everything they had at them, including 36 G-1s built for the Dutch Air Force. The end result of the 5-day battle against powerhouse Germany was a foregone conclusion. The G-1s that took part in the battle were able to smite back at the Germans, strafing infantry units and attacking transport aircraft, but it was not enough. Construction of the Spanish G-1s continued at the Fokker plant, but for a new set of owners. The Spanish order went to the Luftwaffe, who used their brand new G-1s as trainers. Perhaps the best known example of a twin-boom fighter in World War II was Lockheed's P-38 Lightning. Though an odd sight at the time, it would prove a formidable fighter and earn the nickname of Fork-tailed Devil from the Germans. In 1937, the U.S. Army Air Corps was looking for a new aircraft and issued a tough set of specifications to the manufacturers of the day. They needed a twin-engine, high-altitude interceptor with a maximum speed of 360 miles per hour and the ability to climb to 20,000 feet in 6 minutes. The aircraft was also required to use Allison's V-1710 engines with turbo superchargers and preferably have tricycle landing gear. Legendary Lockheed designer Clarence Kelly Johnson was up for the challenge. He experimented with a number of twin-engine configurations, including placing pusher engines behind the fuselage. In the end, he settled on a twin-boom design, much like the G-1 and the FW-189. The lengthy twin booms allowed him to fit Allison's bulky turbo supercharger into a slender aerodynamic housing. With supercharged engines and an aerodynamically efficient airframe, the P-38 became the first American aircraft to break 400 miles per hour. The twin-boom design was unusual for the time and did cause some trepidation for new pilots. There were stories circulating of pilots bailing out and getting decapitated by the props. However, as long as proper bailout procedures were followed, the Lightning was as safe as any other American aircraft in an emergency. Streaking out of the clouds, the Lightning could strike down its opponents with a deadly blow. All of the Lightning's firepower was concentrated in its nose, one 20mm cannon and 4 M2 Browning machine guns, and it had the advantage of pinpoint firing accuracy. The straight-shooting Lightning could consistently hit targets up to 1,000 yards away, sawing aircraft in half in a blaze of bullets. Top-scoring American aces Thomas Maguire and Richard Bong took full advantage of the P-38's precision, racking up 40 and 38 kills respectively against the armorless aircraft of Japan.
Dick Bong was fearless, absolutely fearless. He had one basic rule, and he's told me that on a number of occasions. He said, fly up their tail and blow them away. Don't start shooting a mile away. Run up on their tail, get right on their tail and let them have it. And that's the way he did it.
The P-38 Lightning and the Fokker G-1 were not the only examples of twin-boom fighters in World War II. The Swedes, too, had their own homegrown Saab-21. The Saab-21 was a twin-boom pusher aircraft, just like the Abrams P-1 Explorer. By incorporating a pusher engine, the designers ensured a clearer field of view ahead, unobstructed by rotating prop blades. However, there were legitimate concerns the pilot could get sucked into the propeller blades during a bailout. Although Saab toyed with the idea of jettisoning the propeller in an emergency, they determined an ejector seat was the best solution to the problem. Versatile twin-boom aircraft wore a number of hats during World War II. They were not just excellent spy planes and fighters, they also made top-notch transports. The Gotha Go-242 was a transport glider built to replace the DFS-230. The 230 was limited, as it could carry 9 troops only in tight quarters, and they had to enter and exit via a small side door. The German Air Ministry, the RLM, was looking for a serious upgrade, something that could carry twice as many troops and equipment. Albert Calkert of Gotha was able to give the RLM everything they wanted when he designed the Go-242. The box-like fuselage of this high-wing monoplane ended in clamshell doors, through which 20 troops or a small vehicle could march or roll in. The high twin-tail booms made this door arrangement possible. The gliders were towed into the air by HE-111s or Ju-52s. By adding rocket pods, the Go-242 could be loaded with even more men or machines. It was a widely used aircraft. Over 1,500 were built. Some were even fitted with radial engines when they were converted into Go-244s. America too experimented with twin-boom transports and created their own flying boxcar. With its twin tails, high wing, and low-hung fuselage, Fairchild's C-82 packet plane was the same basic shape as the German Go-242 and 244. The C-82 was designed to replace conventional transports like the Douglas Dakota. Though a workhorse transport, loading wheeled vehicles like Jeeps into the DC-3 was not the most elegant operation, while the low-hung fuselage of the C-82 allowed vehicles to just roll in. Officially named the packet plane, it was aptly nicknamed the flying boxcar, as it had virtually the same capacity as a standard railroad car. The boxcar lost some steam early in its career. The aircraft just didn't have the power to lift heavy cargo. It also arrived late in the war, and only a few were in service by war's end. 223 were built, and some took part in the Berlin airlift. Though the C-82 was something of a disappointment for Fairchild, their packet plane would have a second life. The C-82 was modified into the much more capable C-119. The C-82's high cockpit was moved to the nose of the plane to create more room for cargo. As well, the airframe was strengthened, and more powerful engines were installed to increase the carrying capacity. Maximum takeoff weight ballooned from 54,000 to 74,000 pounds, and troop carrying capacity increased from 42 to 62. The C-82 had been nicknamed the boxcar, but now with the beefier C-119, it was official. During the Korean conflict, the C-119 made a name for itself as a bridge builder. In late 1959, the Chinese PLA destroyed a key bridge between Koto-ri and Hungnam. 8 U.S. Air Force C-119s carried an entire bridge, piece by piece, to restore the escape route between the two cities. Each of the 8 bridge sections were 2,900 pounds and 16 feet long. In the 1950s, other aircraft manufacturers looked to capitalize on the same basic twin-boom design of the boxcar. In France, Nord Aviation produced the Nord Atlas, and in England, Armstrong Whitworth developed the AW660 Argosy. This was a 4-engine turboprop with the cargo space of a typical flatbed truck. Its pod and twin-boom structure earned it the nickname the Whistling Wheelbarrow. In both cases, each aircraft had large doors at the rear to accommodate bulky pieces of cargo. While Nord Atlas and Armstrong Whitworth were interested in these conventional transports, back at Fairchild there was an attempt to create an even better mousetrap. Their XC-120 packplane streamlined the whole transport process. Traditionally, cargo was unloaded from truck and reloaded onto aircraft box by box or crate by crate. But what if there was a universal container that could detach from a truck and reattach onto a flying vehicle, substantially shortening loading time? This was the premise behind the XC-120 packplane. Fairchild took the fuselage of a C-119B and sliced it below the flight deck. They wanted to fit a rolling detachable pod underneath, so they raised the fuselage a few feet higher by angling the wings upward. It wasn't possible to have a traditional nose wheel, so 2 mini landing gear sets were added forward of the main gear. The landing gear was adjustable, so pod loading could be expedited. In addition to carrying cargo, the packplane might carry a specialized mobile hospital pod, mobile buildings, or pods to transport paratroopers. It seemed an ingenious idea, but the U.S. military failed to show any real interest, and instead purchased more traditional transports. The whole idea behind the packplane was crated up and discarded. The 1950s saw the gradual decline and retirement of many of the dependable prop-powered warriors of World War II. The new generation of fighters was jet-powered. Though there were several successful jet fighters in World War II, it took time for this technology to mature. When British manufacturer de Havilland conjured up the Vampire, they chose a twin-boom design to mitigate some of the weaknesses of early jet engines. The Vampire was built around a single Halford H1 engine, nicknamed the Goblin. The engine had only 2,300 pounds of thrust, and de Havilland engineers did all that they could to make full use of the power available. The Vampire was an extremely lightweight plane, made of molded plywood and metal, and it had 2 slender tail booms. Designers chose a twin-boom design to keep the jet pipe as short as possible. If they had used a conventional single tail, the exhaust would have had to travel a few feet farther, leading to a loss of power. The Vampire didn't have the greatest range to begin with, but when fitted with the next generations of Goblin engines, it became a record setter. The aircraft was in fact the first jet to cross the Atlantic when, on the 14th of July 1948, 6 RAF Vampires of No. 54 Squadron RAF traveled from Stornoway, Scotland to Goose Bay, Canada, with stops in Iceland and Greenland. Buyers weren't scared away from buying the Vampire and Ghost combination. Over 3,000 were sold in various configurations to over 30 air forces worldwide. The designers at Saab decided to add some Goblin power of their own to one of their reliable prop designs. Rather than build a new jet fighter from scratch, they chose to retrofit their pusher Saab 21 with a Goblin 2 engine. Back at de Havilland, designers continued to improve on the success of the Vampire design. In 1949, de Havilland unveiled the Venom. Although there were some modifications, this was essentially a Vampire with a new engine, almost twice as powerful, the de Havilland Ghost. In 1951, de Havilland made a much more radical change to the Vampire's original design. They created a twin-boom, twin-engine aircraft with swept wings for the Fleet Air Arm. It was known as the Sea Vixen. The Vixen had a major upgrade in engine power. It used two Rolls-Royce Avon engines with 7,500 pounds of thrust each, enough power for it to reach sound-breaking speeds in a shallow dive. The Sea Vixen had a unique two-seat arrangement.
The pilot's point of view may be that it was all right as an airplane, but what did the observer think? He was in a coal hole on the right of the pilot, and he was completely enclosed in there. And he hadn't much idea of what was going on outside. I would think it was a most unpleasant experience to be an observer on a Sea Vixen.
The Vampire and Venom had both been adapted for carrier use, but the Vixen was a purpose-built carrier-based fleet defense fighter. The aircraft could carry a complement of missiles, rockets, or bombs, including nuclear weapons. In some models, additional fuel tanks could be stored in enlarged tail booms, which jutted out of the top of the wings. The Sea Vixen proved a capable fleet defense fighter, which served the Royal Navy until the 1970s. However, it did have an unusually high accident rate.
Night landing, deck landing is never easier. But a big airplane like this, it had the sad fault that the ailerons became very ineffective at the low speeds at which deck landing are carried out. And this caused problems with lining up the aircraft with the center line of the carrier at night.
Twin-boom aircraft were built with a multitude of engine arrangements throughout aviation history. There were twin jets like the Sea Vixen, single jets, twin prop planes, and pusher planes, just to name a few. But in the 1960s, an aircraft appeared which tried something different. The Cessna Skymaster had a push-pull configuration. There was a prop in the aircraft's nose and another in the rear of the fuselage. Cessna chose this design as safety was the main selling point of the aircraft. It was an interim replacement for the '01 Bird Dog. With a single-engine aircraft like the Bird Dog, there was always the danger that the one engine might fail in mid-flight. The Skymaster's second engine was a fail-safe. As well, with twin-engine aircraft in a side-by-side arrangement, there is the issue of yaw should one engine fail in flight or during takeoff. The centerline thrust of the push-pull configuration ensured that the Skymaster would not veer out of control in these situations. It was a successful aircraft with almost 3,000 produced for military and civilian use. When the U.S. became entangled in the Vietnam War in the 1960s, the O-2, the militarized version of the Skymaster, served as a forward air controller and light observation aircraft, marking targets for heavier fighters and bombers. The O-2 second engine was invaluable should one give out over hostile territory. However, the O-2 wasn't particularly fast with both engines turning. With one damaged, it was a sitting duck. The Skymaster would be succeeded by another twin-boom aircraft especially built for the rough-and-tumble action of Vietnam, the OV-10 Bronco. When W.H. Beckett and Colonel K.P. Rice of the U.S. Marine Corps conceived the Bronco, they wanted to create a close air support aircraft that could operate from jungle roads. Twin booms were vital to the concept. They were impressed by the shooting accuracy of twin-boom fighters like the P-38, and wanted to include a 106mm recoilless rifle along the center line. The tailplane had to be high up on the tail booms just to avoid the backblast. The enthusiastic duo built the fiberglass prototype in Rice's garage, but they had a hard time convincing the U.S. Armed Forces of the benefits of the Bronco. But with things heating up in Vietnam, a specification for a light armed reconnaissance aircraft, Lair, was given the green light by the Navy, Marines, and Air Force. They were looking for a light attack and observation plane to replace the O-1 and O-2, and the Bronco fit the bill. The production version of the Bronco was not quite what Beckett and Rice had envisioned. The Bronco had become a heavyweight warhorse. Over 2,000 pounds of extra electronics, an ejection seat, and a more rugged landing gear meant operation from dirt roads was out of the question. It also lost the recoilless rifle that Beckett and Rice had longed for. The new design wasn't left defenseless, however. It could carry up to 3 tons of external munitions and 4 M60C machine guns. With these alterations, the Bronco still became one of the top-notch counterinsurgency aircraft and remained so for the next 30 years. In Vietnam, the Bronco had a twin-boom stablemate which proved you can teach an old dog new tricks. The C-119 boxcar, which had made a name for itself in Korea building bridges, was tasked with a deadly new mission. In Vietnam, the flying boxcars were transformed into flying gunships. They had a major upgrade in firepower and other equipment to complete the transformation. The AC-119G Shadow was readied for battle with armor plate, 4 Gatling miniguns, infrared sensors, and flare launchers, while the AC-119K Stinger was upgraded with 2 GE M61 Vulcan 20mm cannons and 2 underwing turbojets, adding 6,000 pounds of thrust. In 1986, a twin-boom design attempted a first in aviation, a non-stop trip around the world without refueling. Burt Rutan's Model 76 was extremely lightweight. The airframe weighed only 939 pounds. As there would be no pit stops along the way, every pound counted. The twin booms were essentially huge fuel reservoirs. There were additional tanks in the wings, fuselage, and the canards, and it took 7,000 pounds of fuel to fill them all up. The aircraft had 2 engines, one in the front and one in the rear. The front engine was fired up during takeoff and the early stages of the flight, when the Voyager was heavy with fuel, but it was switched off for the remainder of the voyage. On December 14, 1986, Dick Rutan and Gina Yeager set off from Edwards Air Force Base for a trip around the world. The Voyager had a bumpy start that morning. The wings, sagging with fuel, scraped against the runway during takeoff, but the damage was minimal. Though they had to circumnavigate some hostile weather and had a faulty fuel pump to contend with, the trip went largely as planned. Perhaps the cramped conditions and the stress of the situation were the greatest obstacles of all. After 9 days, 3 minutes, and 44 seconds, on December 23, 1986, the exhausted duo returned to where they had started. The Voyager and her crew were victorious. Their triumph was shared with thousands of cheering spectators and the press who beamed the Voyager's round-the-world trip around the globe. When twin-boom aircraft first appeared, they were an odd bird, but their eccentric designs proved to be a stroke of genius. Designers faced with tough specifications often turned to boomers for the answer. Whether mapping the globe, circling the globe, or leading the charge into battle, time after time, twin-boom aircraft demonstrated their worth. Where twin booms will next take us, we can only guess. The sky is no longer the limit.
Every aircraft has a story that deserves to be told. Don't let these legends fade into the past. Like this video and subscribe to our channel and help us keep aviation history alive.